developed product, DAVrods. But first of all, quickly a profile, of course, so that you know who we are as a university, and the reason why we started the DAVrods project. Then Chris will take you through the architecture, do a demo. Yes, another demo, late afternoon. That'll be a quick one, and then a wrap up and Q&A. So hopefully we won't spend too much of your time, but hopefully it's valuable to you. First of all, Utrecht University. Well, we've been erected in 1636. We're the largest university of the Netherlands, meaning that we have about 30,000 students, so that's probably a moderate scale for other countries, and about 6,000 employees. Out of those 6,000, there's 4,500 researchers, and those researchers are in desperate need of IT support. So we created an IT strategy, research IT strategy. 2 years ago we started the concept of that. Actually, the program itself starts this year. Okay. So we've joined the iRODS consortium, and why did we do that? Well, basically 3 reasons. Most important reason is actually we love iRODS. It's a key component to our IT strategy, and as you've all seen today, there's so many good things about iRODS and how you can deploy it. We really like it to be an integrating architecture, as one of the few that integrates both metadata and data as such. And I've read the work, and it's unique as such. And we have 2 purposes for it: to manage the integrity of our data and to collaborate on it. Those are hard things to do. We try to accomplish it, but those are hard things to do. Those are also hard things to combine. If you look at today's, you see some of the things that are all about collaboration, you know, how do you access the data, more or less random access. The other things are about, you know, well, how can you store it in such a fashion that it's read-only, or you have it in a kind of a vault, and make it available, and you can see through all the steps that have been taken, auditable fashion. So we are also on that journey just like you are. We want iRODS to be continuously available to us, to be maintained, to have continuous innovation. And that is a primary goal that said, well, okay, if we chip in some money for that every year, that's only fair. So we hopefully, those of you that aren't a member yet, we hopefully have also set a bit of an example, and please join us in joining the consortium. Secondly, we love to connect with the development team and with other iRODS members and other iRODS users. Now, you don't have to be a consortium member for that all the way, but it does make life easier, doesn't it? Doesn't it, Jason?
Of course.
Of course. There you are. And thirdly, well, on the last part is influence the roadmap. But the most important part for us is to understand and anticipate the roadmap, so that we can plan our strategy accordingly and understand how we can put iRODS to the best of use in our IT strategy. So those are the main reasons, and hopefully, if you're not a member yet, it will inspire you. Then up to DAVrods. Well, what did we find? Last year we were here, we presented our Yoda project, which was really about managing data on 6,000 subjects. We started all that off. We were on iRODS 3. At that point in time, we used WebDAV as WebDAV access. And we were talking about a friendly user interface. Because these researchers also need, lots of researchers want just a friendly interface. So why did we deploy WebDAV? Well, most importantly, it's a standard. So there's no vendor lock-in. All platforms can support it, yes, it does. But then secondly, the connectivity. We have lots of researchers with lots of other research from other countries or from the same country that need to collaborate together, and it's a real pain working together on the data. So to make that happen, we need things like being able to share the data across firewalls of other institutes. And HTTP, while not being the fastest protocol, so one of the few protocols that provides you all that connectivity across. So that's why it's important to us. So for moderate sized data, we're not talking about transferring terabytes of data here, but for moderate sized data, then it provides a very easy means of accessing data. Thirdly, I already mentioned it, user experience, very friendly, native user access. If you're on an Apple, like most researchers tend to be, they use the Finder interface with a network drive and you're up and going. If you're on Linux, you mount it. If you're on Windows, you better choose a different... Okay, no, then you are... Well, you have a couple of choices. You can use Cyberduck, you can use NetDrive, and those are the two choices that we prefer. We hate to go the native Windows way because that's a little bit iffy. So you need probably a little driver to tuck in between. But then it's up and running. So, and security, that's one that's probably underestimated. We didn't want to expose the iRODS API outside our campus. Simply because we are not sure whether it's hardened enough yet for that purpose. So, as a security thing. So we wanted to have more control over the functions that we would expose to the users. We're happy to federate with our zones, specific connections, but not just open to the internet. So that's another area where WebDAV comes in, since it will basically be sort of a gatekeeper that will help us to have people access data in a secure fashion. So those are the goodies about WebDAV. Now there was a real showstopper going to RS4 for us, because we wanted to migrate and get all the goodies from RS4, but there was no WebDAV at that point in time available. WebDAV was no longer maintained. Mike was doing a great job in creating iRODS WebDAV, but it was not ready yet. There were some other initiatives, but none of them as a release available to us. We waited and we waited until we got tired of waiting, and by October we decided, well, we're going to do it ourselves because we need it desperately. So we can't wait anymore. And that's where the DAVrods project came in. So, what are the design goals that we set ourselves out to create this? First of all, we want a WebDAV Class 2 compliant interface. In particular, the Apple devices required it, otherwise you don't get any read-write access, you only get read access to your data on a WebDAV device. But in general it's quite convenient, of course. Secondly, well, our users already had WebDAV, so the performance needed to be similar to or better than WebDAV. We couldn't deteriorate the performance, we couldn't have that. So that was another design goal. Clearly it needed to be available quickly, we have waited too long. And another thing is that we want to have federated authentication. Not federated in the iRODS sense, but federated in terms of like eduroam you get over here, so that we can have people authenticate with their own institute credentials and access iRODS or other services. We're working on that in the Netherlands in collaboration with the National Data Center. So we're pretty far on that already. We expect to have an initial release of that part by the end of the summer or maybe in fall. But to do that, and to use that technology, we needed to use PAM access from iRODS. So we could use the authentication plugin to call out to that federated authentication part. So we said shoot, because if it wasn't there yet, we could still live with it for a while, but we really want that. And then next, as simply part of the societal responsibility we feel we have, we wanted to create it as an open source project and maintain it as an open source project. Well, those are the design goals. And then Chris, it's up to you. Can you build that for us?
Well, I did. So we took the Apache DAV support as a starting point, because we know Apache is a widely used piece of server software, and the mod.dav module for Apache is generally considered the reference implementation of WebDAV. So it should work with pretty much all clients. Also, using Apache allows for a very easy configuration. It allows us to easily enable HTTPS over it, and so on. So what we have developed is an Apache module called DAVrods, which supports WebDAV and translates WebDAV calls to calls specific to iRODS for accessing data objects, reading collections, and yeah, downloading them, uploading, and the like. Also, Apache allows us to use WebDAV class 2 with built-in locking support. So we use the C API, the official C API of iRODS, and we can use that to enable PAN authentication and be compatible with iRODS 4. So the WebDAV support in Apache is set up in a very modular way. We can pick and choose different components to supply different WebDAV functionalities. So DAVrods is a combination of components, of providers, they are called, which together form a bridge between WebDAV and the iRODS server. So we don't have to talk the WebDAV protocol ourselves. We let Apache do that for us, so we can be sure we speak the right language, and yeah, that makes it very reliable. So we have three providers from mod.dav that we implement. First one is the repository provider, which translates calls to access directories and files to iRODS collections and iRODS data objects. Then we have properties, which are sort of like metadata. We currently only provide system metadata, but it could be extended to allow the client to request any type of metadata stored in iRODS using WebDAV. And there's also logging. Unfortunately, the logging support in iRODS is not exactly compatible with WebDAV. So to still be able to support WebDAV class 2, we had to make a local log database on the Apache server, so we can still provide WebDAV class 2 support. And unfortunately, the logs are not in sync with other possible instances of this DAVrods server or other iRODS clients. We tie the lifetime of our iRODS connection to the lifetime of the HTTP connection of the client. This allows us to combine multiple requests to iRODS within the same authentication, so we don't have to log in every time for every HTTP request. This can be finely tuned using Apache configuration directives, using keep alive settings. So it's very flexible in that sense. But we also destroy the iRODS connection when the user disconnects or the keep alive limit is reached, so we don't tie up the iRODS agent on the server. This is an example configuration for DAVrods. It feels just like any other Apache module. You specify a location in which you want to enable DAVrods, for example at the root directory, which we recommend because not every client can handle a DAV server at a subdirectory in the namespace. So we have the most important configuration options here, which are the server we connect to, the iRODS server, and the port, the zone to use, which authentication scheme. We support both native and PAN authentication. You can optionally specify a default resource. If you leave it out, you let the server decide. And you can switch between the root directory on iRODS you wish to expose. So we have set it to home here, which is the zone name and then home. But it's not the default. The default is user, which goes to the home directory of the connected user. We'd like to make home the default, but unfortunately the /home directory is not readable by everyone by default in iRODS 4. So we set the user directory as the default here. You can also specify an absolute path if you want. It all works. And now for a demonstration. I'm going to install DAVrods on a server which also runs iRODS currently, where HTTP is already installed. And then next to it I'm going to connect to it using a Debian VM running GNOME. Need to switch monitors real quickly. Seems to work. So we start yeah, thanks. Starting the iRODS server and the client. Right. The iRODS server is running CentOS 7.
Oh shit. Oh, nice and cozy, huh? Cool it off.
So I have a CentOS 7 VM here running iRODS and running Apache. We have packaged DAVrods as an RPM for CentOS 7, so we can install it using YUM. We also need to install the iRODS runtime RPM, which is a dependency of DAVrods. There we go. It's installed. DAVrods ships with an example configuration, which is a simple vhost file for Apache, which we'll edit right now. I'll include this. Oops, caps lock again. Switch to port 80. Of course, we support SSL as well, but I don't have a certificate for this demo. Okay, now we restart Apache. So it should be up now. So we go to our client VM. Let's cut off the screen, I think. Let me check. So of course this depends on the operating system you're using and the desktop environment in the case of Linux. But in GNOME it's as easy as saying connect to server, and then we select WebDAV. DAVrods. this demo we're going to use the RODS user. And there we have it. This is the home directory of the iRODS admin. So we can create a collection there. Test. We can create a file. So you want to give me a string of text to insert here?
iRODS is great.
iRODS is great. All right. Okay. Well, let's check if it has arrived on the iRODS side. You go to iRODS. I see the test directory. There we have it. Well, that's the end of the demonstration. You see, it just works. Quite easy to set up, quick to install. Yeah. Well, now we need to see how it performs. So, you can connect back to the old laptop. Yes, please.
Warning for that. Burn.
So, we've run some performance tests in our little testing environment. It wasn't set up to be highly performant, the environment, so we don't have a very high-speed network connection. It runs in a VM, multiple VMs connected in a virtual network. So we see a comparison of different file transfer operations with a comparison between WebDAV and DAVrods. And with two different clients, we've tested both curl and cadaver. So in general, it seems DAVrods performs 10 to 50% better than WebDAV. The only case where you have a very strange data point is using cadaver to get a 1 gigabyte file, which strangely runs in half the time. We haven't completely figured out what caused it yet, but we think we should be able to work around it because the other tests ran much better. Might have something to do with HTTP transfer options, but we're going to look into that. Back to you.
Thank you, Chris. Let's then have a look at if we've met our design goals. I think we met a lot because we now can support a variety of client platforms. Okay, got that. Performance is reasonably okay, Chris. Still need to work on a single thing, but no, we're happy about it. We're really happy. I'll confess to you, we're using it in production already quite a lot. So we've actually been able to migrate to 4.18 all our systems, in Q1 2000 this year actually. So we don't have any RS3 system anymore, except that we left one over for the performance benchmark to be able to compare old and new environments. Yes, you support PAN. We haven't seen it yet, but I know because we use it in production, so that's good. There's only one little piece over there left. It should be managed and packaged as an open source product. So, how do we fix that? Oh, next slide, please. Well, here we are. Well, we hope to have completed it before this conference. But Chris has some other duties to fulfill as well. He's studying, so. But that's complete now for this year. So after the conference, we'll package DAVrods as an open source product. We have a lesser GPL version 3 as a license for you. We'll push the source on GitHub and then also a binary packaging, the RPM that you just saw already built. And if people are interested, we could also do a Debian package. And are there many Debian Ubuntu users over here? Raise your hands. Any interest? Are you using it?
Sorry.
Okay, no, it doesn't seem to be a big priority. But we, otherwise, contact us if you need it, because it shouldn't be much of an issue. And I think we might consider it anyway, if we can manage that as well. So that should be available. The link you see over there is right now filled with an empty repo, and that will be filled with all of it by the end of June. Thank you so much. I'll give the floor to who?